All right, Dr. Burks here again. So we're going to continue part B using a graduated cylinder instead of a beaker to measure out 10 milliliters of water. So we're basically doing the same process that we used with a beaker, but with a graduated cylinder. All right, so you'll notice on this graduated cylinder, it has many more markings on it than that beaker did, right? So that probably implies that it's going to be a little more accurate than our beaker was. So we're going to start by weighing the empty graduated cylinder. Again, on our balance, it's zeroed, and then we'll put it on there and you'll record this mass. And this is the mass of the empty graduated cylinder. So now we're going to measure out 10 milliliters of water into this graduated cylinder. So I've got my beaker of water again, right? So we'll add water to this graduated cylinder up to the 10 ml line. So I'm actually going to kind of pour this with the beaker so it goes a little faster. And I went a little over the 10 ml line. So what I'll do is just pour a little bit of this out. All right, so now I went back under. So now I'm going to use my pipette so it can go a little more slowly and fill it up to the line. So when we're using this graduated cylinder, you can tell that there's a meniscus in the water where it's kind of curved down. So we want the bottom of that meniscus to be at that 10 ml line. So that's about it. We'll maybe do one more drop. So that's then 10 mils into our graduated cylinder. All right, so now we're gonna weigh this again on our balance. So you're going to want to record this mass as the mass of the graduated cylinder with 10 mils of water in it. So now we have the mass of the empty graduated cylinder and the mass of the graduated cylinder with 10 mils of water. Again, just like in the last part, you can subtract those two to get your mass of water and then use the density to determine how much the volume of water is inside the graduated cylinder.